We have a polynomial here with two terms. In the first term we have number and a variable, and the next term we have only number. That means the next term is a constant term. Now from these two terms I will take out the greatest common factor. As here we have 18 and here we have 12, let's find out the GCF of 18 and 12. 18, 2, 9, 3, 3, and 12, 2, 6, 2, 3. We have 2 and 3. So the GCF will be 2 multiplied by 3, that is 6. So the GCF of the numbers is 6. I will write 6 here. We have x in the first term, but we do not have any x here for the next term. So we cannot take x as common. Now what we have left here, you will divide 18x with 6. If you divide, you will get 3 here and x remains. So 3x for the first term. Next term, if you divide 12 with 6, you will get 2. This is how we take out the common factor, greatest common factor of the polynomials. Take the GCF of the terms you have here. Here I have two terms, that means it's a binomial. So from those two terms I have taken out the GCF. That's the factorization for this polynomial. It is written as the product of its prime factors. Let's have some other examples. Another binomial here. We have numbers and variable x with both terms. Let's find out the GCF of the numbers first. 8, 2, 4, 2, 2. Then 6, 2 and 3. So what is the GCF here? 2 and 2. So the GCF is 2. Now we have x here and here both, but the powers are different. Look at the powers of the x. We will take the smallest power of the x. Here the smallest power is 2. So we will take x squared. Now the same way we will do here. We will divide this term with 2x squared. So 8x cubed divided by 2x squared. If you divide 8 with 2, you get 4 here. And if you divide x cubed with x squared, 2 of the powers will be gone. So only one power will left here. So we have 4 and 1x left. Next, you will divide 6x squared divided by 2x squared. You cancel here, you get 3. If you simplify, you get 3, and x squared and x squared will be cancelled. You get only 3 here. That is your answer. This polynomial is written as the product of its prime factors. We have 18 and 12. We know the GCF is 6. Now we have x here and here. The power of x is 2 and the power of x is 1 here. We will take the smallest power of x. So we will take x here. And we have y and y cubed and y to the power 5. We will take the smallest power. So we will take y cubed. Now if you divide 18 with 6, you get 3. And here we have 1 power of x, only 1, and here we have power 2, 1x. Y cubed here and y cubed here, both will be cancelled, so no y here. Next, if you divide 12 with 6, you get 2. And x will be cancelled. Y to the power 3 we have here, and we have 5 as a power. So y square is left here. We have another polynomial here. It's a trinomial, and let's take the GCF of the numbers first. We have 21, 14 and 35. If you take the GCF, you will get 7. And here we have x, here also we have x, here also we have x. What is the smallest power of x? We have 2 here, 3, 2. So we will take x squared. We have y square here and y. So we have to take y. Z square here, only one z here, no z here, so we cannot take z. Now divide 21 with 7, you get 3. X squared will be cancelled. Y square here, y here, we get 1y from here. Z square, we do not have any z here, so z square remains with this. Next, if you divide 14 with 7, you get 2. You have x cubed here, x squared here, so 1x is left. Y here and here also y cancelled, and we have z here, z will remain. 35 divided by 7 will be 5. X squared will be cancelled. We have y here, here also there is nothing left. We have another polynomial here. It looks different, but it's actually the same. 2x is multiplied with x plus 4. Here 3 is multiplied with x plus 4. So this is a term and this is another term. We have something common here. Here we have 2 and 3. There is nothing we can take from here. But we have x plus 4 in both the terms. So we can take x plus 4 as common. If you take x plus 4 from here, you are left with 2x. So we will write 2x here, plus if you take x plus 4 from here, you are left with 3 here. So write 3. This is how we take out the GCF from the polynomials.